Hey, hello friends, welcome back to the channel. This is Ahili Bhattacharya, your stats buddy, and today we are going to cover correlation and regression. I know, I have covered this topic, but here's the thing. This is one of those topics that really benefits from coming back to. It's not always easy to grasp all the connections on the first try. So, I'm making this video as the ultimate review session. We are going to walk through this concept slowly, connect all the dots, and make sure everything is crystal clear and easy to follow. Whether you're preparing for an exam or just want to feel confident about this topic, this is the video for you. We'll cover everything up through regression analysis today. In my next video, we will pick up right where we leave off and dive into the least squares linear equation. Sounds good? Let's get started with our first slide. All right. Part 1. The big picture. It's all about relationships. Let's start with the fundamental shift in thinking. Most introductory statistics deals with univariate data. All right? One measurement per item, like the height of each student in a class. But statistics gets really powerful when we look at bivariate data. This is where we have two measurements for each item, allowing us to ask, are these two related? Classic examples are everywhere. First, hours you study and your exam score. Number two, temperature outside and number of cold drinks sold. Number three, a person's height and their weight. See, our goal is twofold. First, correlation. What is correlation? To measure how strong and in what direction that relationship is. Number two is regression. To use that relationship to predict one variable from the other. Okay, coming to the next slide. See. Part 2. What is part 2? The visual. Your first step should always be a scatter plot. Before you calculate a single number, you must look at your data. The best tool for this is the scatter plot, as you can see in the graph. Each dot on this graph represents one pair of measurement. When you look at a scatter plot, you are looking for three things. You can see here. Number 1, form. Is the pattern a straight line or a curve? Number 2, direction. Does it slope upwards or downwards? Number 3, strength. Are the points tightly packed in a line or they are scattered everywhere? See, you will generally see a classic few patterns here. As you can see from this graph only, positive correlation, negative correlation, and no correlation. See for the next slide. As I said, that you'll see a general few patterns. First is strong positive, a clear upward trend. Next is weak positive, a vague upward trend with lots of scatter. I'm sorry. Number three, strong negative, a clear downward trend. Number four, weak negative, a vague downward trend. And no correlation, as you can see in the previous slide, that a random cloud of points with no pattern. See, a quick terminology check. We often call one variable the independent variable x, the one we think is doing the influencing, and the other the dependent variable say y, the one we think is being affected. We always plot x on the horizontal axis and y on the vertical axis. Okay, coming to the next slide, which is part 3. The number, correlation coefficient. A picture is great, I know that, but we need a number to summarize this relationship too, right? That number is the Pearson's correlation coefficient or R. Think of it this way, the sign, positive or negative, tells you the direction of the relationship. The value closer to plus 1 or minus 1 tells you the strength of the linear relationship. As you can see the formula here, covariance x and y divided by sigma x and sigma y. What is sigma x and sigma y? If you can recall, sigma x is standard deviation of x and sigma y is standard deviation of y. Okay? Yes, so now coming to key facts about R, the crucial properties as you can see. First is it's a pure number with no units. Number two, it's symmetric. Rxy is equals to Ryx. It doesn't care which variable is x and which is y. And number three, it's always lying between minus 1 and plus 1. Okay? I said that it's a pure number with no units. By that, what do I mean? You can correlate height and weight with no problem. That's very interesting, right? Yes. Coming to the next slide. Part 4. The crucial warning. What correlation can and cannot. See, this is the most important part of this review. If you remember nothing else, remember this. Correlation has major limitation. First, it only measures linear relationship. Correlation is completely blind to anything that isn't a straight line. As you can see, this parabola, look at this. This is a perfect relationship, y is equals to x squared. But if you calculate the correlation coefficient here, r, it will be 0. This is the number one key takeaway. R is equals to 0 does not mean no relationship. It only means no linear relationship. Alright? Number two is correlation does not imply causation. Just because two things move together, it doesn't mean one causes the other. This is a classic logic trap. See, this leads to a vital statistical truth. If two variables are independent, their correlation is 0. No, this is not written here. Let me tell you this, okay? This is the written as a theorem. Let me explain you. See, if two variables are independent, their correlation is 0, r is equals to 0. That makes sense. No connection, no linear relationship. However, the reverse is not true. If you find that r is equals to 0, you cannot conclude they are independent. They might have a very strong linear relationship, non-linear relationship. Just like our example here, y is equals to x squared, right? Yes. Now coming to the next part, part 5. From description to prediction, regression analysis. All right, let's say we have found a strong linear relationship. This is where we move from just describing the relationship to actually using it. This is the goal of regression analysis. In simple terms, regression uses what we know about one variable x to predict the value of the other variable y. The tool we use is a regression line, a line that, a straight line actually, that best describes how y changes as x changes. Now, how do we find this best line? We use a method called least squares. The core idea is to find the single line that minimizes the total squared prediction error across all our data points. The result is our prediction machine, the least square regression line, which has the standard form y cap is equals to a plus bx. Okay, where y cap is our predicted value for y and ab is the slope and a is the y-intercept. Now, the real magic and the core of the next video is the understanding how we calculate the values of a and b. How does the least square method actually work? What are the formulas and why do they look the way they do? Okay? This is exactly where we will begin the next time. In my next video, we will start from the ground up with the least square linear equation, deriving it step by step so you not only understand what it is but why it works. Okay? Now, it's done and conclusion and wrap up. So let's wrap up what we have solidified in this review. First, the purpose of bivariate data. Number two, how to visualize relationship with a scatter plot. Number three, how to measure them with the correlation coefficient. Number four, the critical limitations of correlation and the transition to regression for making prediction. You now have a rock solid foundation, right? You understand the what and the why. In our next video, we'll master the how. If this review helped clarify things, let me know by hitting that like button and subscribe for the next part, which is where we tackle the least square equation. So, yeah, thanks for watching, and I'll see you in the next one. So, bye bye, study hard. Ta-da.